All right, we are back. This is Calculus 1. We are in Chapter 5. We're doing 5.6. It is on page 31 of your note packet. Integrals involving exponential and log functions. So you should definitely have e to the u du is equal to e to the u plus c memorized. Memorize that. This one, don't memorize. You don't have to worry about this. What is it? A to the u du, and that's 1 over ln a times a to the u plus c. Don't memorize that. We don't have to worry about that. This you should have down, though. You should know that the integral of e to the x is e to the x. All right, so let's go into examples. Negative x dx, so you can say u is equal to negative x, du is equal to negative dx. Since there isn't a negative on the dx, we solve for dx. Divide by negative 1. So dx is negative 1 du. So we have to replace that. So when we do our u substitution, it's e to the u, all right? And then negative 1 du. And so that negative 1 gets pulled out in front. And now that is just e to the u plus c. And then, so it's negative e to the u plus c. And now you got to remember to put the x back in there. It's not a definite integral. And so we need to put x back. And there we are. All right, so resubstitute in the x values. Let's look at the next one. Number 2, we have, what do we have? E to the, is it 5x? 5x plus 1. Man, that's tiny. Dx. All right, so u is equal to 5x plus 1. Du is equal to 5 dx. Problem, we don't have a 5 there. We just have a dx. So we want to solve that out for dx. Divide both sides by 5s. 1/5 du equals dx. Now we can do that substitution in there. So let's substitute e to the u 1/5 du, and let's pull the 1/5 e to the u du. Let's integrate. So that is e to the u plus c, and then 1/5 e to the 5x plus 1 plus c. Okie dokie artichoke. Well, let's look at 3. 3, 3, 3. 3, 3. I see. All right. Number 3. We have, oh boy, what is that? E to the sine pi x. What a weird power. E to the sine pi x. And then times cosine pi x dx. Okay, I think this one is actually a lot easier than you're going to think it's going to be. So u, let's call that u, sine pi x, and then let's do du. The derivative of sine is cosine of pi x, and then you got to multiply it by the derivative of whatever is inside of there, which is pi. All right. And then dx. Okay, so we're missing a pi. We got this. We got cosine pi x dx. So we got cosine pi x dx, but there's this extra pi hanging out here, so we got to divide that out. And so you got 1 over pi du is equal to cosine pi x dx. And now let's sub in everything. So e to the u. And then all of this is really just that. So 1 over pi du. And now we can pull that constant out front and then do the derivative. So 1 over pi, or the antiderivative. Sorry, the antiderivative. Du. 1 over pi e u plus c. And now we have to put the u back in. So 1 over pi times e to the sine pi x plus c. Okey-dokey. Let's look at 4. So we've got the integral of 2x to the third e x to the fourth dx. Interesting. All right. So again, let's go with u as the power on the e, x to the fourth. So du is 4x to the third dx. And now let's examine and see what we got. Well, we don't have quite that. We got the x to the third, and we got dx. But we don't have a 4. So let's divide out that 4. So we got 1/4 du, and now we got x cubed dx. And again, we can rearrange this if it's a little easier for you. We'll leave the 2, we'll leave the ex to the fourth, and then we'll say x to the third dx. And now you can see the substitution. We're going to take this, and we're going to pop that in there. See how those are the same? So let's put in our u's. And now we got the 2 there still, so it's 2/4 or 1/2. And we'll pull that out in front. And then du. And then replace that back with the x to the fourth. And there we are. That's it. And we're done. So yeah, after you do some of these, right? Hopefully you're getting the hang of this and you're seeing it as not that horrible. You really build on these skills in Calc 2. So we're on to, what was that, 5. So e to the x, square root of 5 plus e to the x dx. Interesting. So let's say u is equal to this, 5 plus e to the x. And then du would be equal to just e to the x dx. And now look, we got an e to the x dx. So that was the right move. We don't even have to divide anything out or anything. So here, we'll rewrite it. But that was the derivative of that, exactly. And so now we can replace this with u, and we can replace this with du, And now let's make that to the 1/2 power. I should have did that in one step, sorry. And now do the antiderivative, so add 1, so that's u to the 3/2, and then times 2/3, and then plus c. Okie dokie. And now put it back in. Put back in 5 plus e to the x. So you got 2/3 times 5 plus e to the x to the 3/2 plus c. So yeah, that was easier than most of them. So good to go. Now they have a few definite integrals, so let's take a look at those. Number 6. We've got from 0 to 2, e to the 2x dx. So we're going to say u is equal to 2x, du is equal to 2 dx. Problem, there's not a 2 there. So we got to fix it because we just have a dx. So divide by 2. So we got 1/2 du equal to dx. And now we can take our definite integral and we can substitute a u there, and we can substitute a 1/2 du there, and then the 1/2 will go out in front. 0 to 2 eu du, and then 1/2 times e to the u, and now there's no plus c anymore. That's from 0 to 2. And we got to put the x back in there. There's two things you could do. You could put in 0 there and change that to 0 and that to 4 and just leave it eu, or we can just put in the 2x. We're just going to put in the 2x. e to the 2x from 0 to 2. And then remember, it's always upper minus lower. So we have 1/2 times e to the 2 times 2 minus 1/2 times e to the 2 times 0. And again, do not get in that nasty habit of just saying, oh, there's a 0 there, it's just going to be 0. It's not going to be 0. This is going to be e to the 0 power, which is 1, but then there's still a 1/2 there. So we have 1/2 e to the 4th minus 1/2 times 1, or we can just leave it like that. We can just say 1/2 e to the 4th minus 1/2. That's fine. Or I know some students right away when they see the 1/2, they want to factor it out and go e to the 4th minus 1. That's fine. You don't really have to factor out the 1/2 if you don't want to. All right. Lovely. Let's look at the bottom of page 31. 2 more problems here. Well, that was the only definite integral we had to work with. We got 5 to the negative x. Dx. All right. So this, we're going to need to do that one that I said don't memorize. So here, let's write that down. That's what are we going to do it with? A to the 4th du is equal to 1 over ln A times A. I think that's an x. Plus c. So that guy. We're going to do that with this. So here, we can still do the u, or maybe that, oh, that was supposed to be a u. This is supposed to be a u. This is supposed to be a u, not an x. Okay. So we're going to say u is equal to negative x, and then du is equal to negative 1 dx. Dang it. We got to divide out the negative 1. So you got dx is equal to negative du. And so there we are. Let's put in our u and our negative du. And so pull the negative 1 out front as a constant, and 5u du. And now we're going to work that magic. So negative 1 times quantity 1 over the natural log of 5 times 5 to the u power, and then plus c. And then we got to put our x's back in. So we got, what do we have then? Negative x, right? Negative x. All right, so we have negative 1 times, let's just put the negative on the top. Negative 1 over ln 5 times e to the negative x minus c, but really plus c. It doesn't matter. You don't ever put a minus usually on the constant, because it could be minus a negative or a plus. It doesn't matter. So the negative doesn't really transfer to here. There you go. All right. No. You can leave it like that. That's fine. Or we could move that. Oh, wait. I made an E where there wasn't an E. Don't make an E where there wasn't an E. That was a 5. Okay. So you could take that and pull it down if you want to. So we have negative 1, 5 to the x power ln 5 plus c. This is fine. This is also fine. You could leave it like that. Just don't do what I did. Don't put an E there. That's a 5, not an E. Oops. All right. Let's look at 8. Finish off page 31. And what do we have there? We got 3 to the x over 2 dx. So we'll rewrite that as 3 to the 1/2 x dx. A is equal to 3, u is equal to 1/2 x, du is equal to 1/2 dx, and of course there's not a 1/2 dx up there, so you gotta solve for dx. That's 2 du. And so now let's do our substitutions here. We've got 3 to the u 2 du, and then pull the 2 out in front of the integral, 3 u du, and now work the same magic that we did last time. So we've got 2 times 1 over ln 3 times 3 to the u plus c. And then put in 1/2 x back into where u is. So what do we have? We've got 2 times 3 to the 1/2 x over ln 3 plus c. Lovely doubly. So that was page 31. 32, page 32, recall the derivative rules of log functions. Okay. And you should know that. We'll write those down. So, The first blank there is ln, the absolute value of x, plus c. And the second blank over u du is ln of u, the absolute value of u, plus c. So, same thing, just with a u instead of an x. All right, this is the general case in the case for x. Integrate the following. Okie dokie, let's do it. Number one, we're integrating 5x to the negative 1 dx. Let's rewrite it. Let's pull the 5 out in front and then call this 1 over x, or, I mean, we don't have to, but it'll look like that then, right? 1 over x dx, and then you could just integrate that sucker on the spot. It's just going to be 5 ln absolute value of x plus c. Done. So pretty quick problem. 2. Oh, they have Roman numerals. 1 over 3x minus 4 dx. Okay, so this is going to take a little more of our brain power here, because we're going to, here, let's rewrite it, do a quick rewrite. Let's call u 3x minus 4. Let's call du 3 dx, and then we have to fix it. Divide by 3, divide by 3. So I got 1/3 du is equal to dx. And so now we can sub in u to the negative 1, and then dx is 1/3 du. Pull that 1/3 out in front of the integral. Write that as 1 over u du. And now we get to do that again. So here. What do we have? 1/3 ln, where am I? On number 2. Ln the absolute value of u, and then plus c. Right? So easy peasy to integrate that. It's just 1/3 times that. And then don't forget to put the 3x minus 4 back in there. So 1/3 ln of the absolute value of 3x minus 4 plus c. And there we are. Done. All right. Well, let's look at 3, 4, 5, 6, 7, 8, 9, 10. Whew. All right. This one, 3. What's going on with this? We have x squared minus 4 dx. Interesting. So again, we might want to think of this like this. X over 1 over x squared minus 4 x dx, like that. And so let's say u is equal to x squared minus x. So du is equal to 2x minus 1 dx. And what do we have there? Oh, I took down the wrong problem. So don't take down the wrong problem. That's a 4, but then when I rewrote it, I made it an x. Sure, don't do that. It's going to say, oh man, this is going to be tougher. But it's not going to be tougher, because it's going to just be this. 2x dx. And we have the x dx. So we just have to divide out the 2. So 1/2 du, and then I can sub in x dx for that. And this is going to be 1 over u. So 1 over u is, and x dx is 1/2 du. And then we'll pull that 1/2 out in front of the integral, and 1 over u du. And now we've got our ln stuff going on here. So for number 3, what are we looking at here? 1/2 ln u plus c. Oh, absolute value of u. Absolute value of u. Don't forget the absolute value sign. Ln. And then x squared minus 4. Okie dokie artichoke. So don't make the problem harder by writing down the wrong problem. That's the worst. Let's look at number 4. We have x plus 1, x squared plus 2x dx. So again, let's take a look at this like this. 1 over x squared plus 2x, and then times x plus 1 dx. And so u is going to equal x squared plus 2x. And then du is going to equal 2x plus 2 dx. And you might say, no, but that's not what's there, and it isn't, but oh, it's so close. If I factor out a 2, look. So it's just off by a factor of 2. We'll just divide out the 2, and now we have matched it. So this x plus 1 dx matches this x plus 1 dx, so I can replace it with that. I can replace that with u, and this won't be a bad problem at all. Just have a 1/2 du there. Pull the 1/2 out. I'm looking at 1 over u du. This has been a very familiar thing, right? ln u plus c. And then crank back in our x squared. Oh, not with a parenthesis though, with an absolute value. X squared plus 2x plus c. Voila. All right. So yeah, it's important that you don't look at it like a fraction. Look at it as 1 over this, and then that's all the leftover stuff. That works out a lot better that way. All right. What the heck are we on? Number 5. Let's take a look at 5. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. We have 7, 5x minus 4, dx. Yeah, I don't know what we're going to do with that. Let's see. That 7 we might want to just pull out in front right from the go here. X minus 4 dx, like that. That 7 is not going to help there because we're going to say u is equal to 5x minus 4. Du is going to equal 5 dx, and then I got to divide up the 5 because there's not a 5 there. And so we got 1/5 du is equal to dx. So we got 7, and then we got 1 over u, 1/5 du. And now let's pull that 1/5 out front. That's 7 over 1. So we can multiply those. So we got 7/5 integrate 1 over u du. And now, right, it should almost be in cruise control here. Ln, absolute value of u, plus c. And then u is 5x minus 4. So 7/5 ln of absolute value of 5x minus 4 plus c. Okie dokie artichoke. Lovely, lovely. And then let's look at number 7. I need a new black marker. These black markers are dropping like flies, I say. How are we doing for time? Oh, 29 minutes already. All right, number 6. Oh, good. I was worried we weren't going to see some trig. We love ourselves some trig. With integration, right? All right. We got secant squared x over tan x dx. Again, let's look at it like 1 over the tangent of x, and then times secant squared x dx. And let's say u is equal to the tan x, and du is equal to secant squared x dx. And look at that, everything matches up just lovely. So we can say 1 over u du, right? That is exactly du. I didn't have to divide or multiply or nothing. And so we're looking at ln u plus c, and then we're going to put in the tan x. Don't forget to put back in terms of x. And that was a quickie. We like those sometimes. All right, let's take a look at 33, 34. All right. So page 33, what are we doing? Tan x dx. So we're on page 33. Tan x dx. Yeah, I think we're going to want to look at this as rewrite here. Let's rewrite it as sine over cosine dx. And then we can work from there. So we can say u is equal to the cosine of x, and then du is equal to negative sine x dx. And see what we got going on if we write it 1 over cosine x times sine x dx. It's so close, it's so close. We just have a negative 1 we have to fix. So negative du is equal to sine x dx. And now we can sub that in exact. So it's 1 over u negative du. And then pull that negative out front. And then integrate it. So we're 1 ln absolute value of u plus c. And then replace that with cosine. So negative natural log of cosine of x plus c. Okie dokie. Okie dokie. Let's look at 8. So 8 is, oh, look at this monster, huh? 3x squared plus 1, 3x cubed plus 3x dx. So again, let's say this is 1 over 3x cubed plus 3x times 3x squared plus 1 dx. I'll say u is equal to 3x cubed plus 3x. du is equal to 9x squared plus 3 dx. And that is not that, but look carefully. It's only off by a factor of 3. And that we can fix by dividing out 3. So we got 1/3 du is equal to 3x squared plus 1 dx. And now this exactly matches that. So we can replace. We got 1 over u and we've got 1/3 du. And then the 1/3 goes out in front. And we do our magic. And absolute value of u plus c, and so it's 1/3 ln absolute value of 3x cubed plus 3x plus c. Okie dokie. Oh, I see. All right. So this is fine. This is fine. This is good. But I I remember on a long time ago when I was teaching calc, the student had this for an answer. And at first, I got out my red pen and started marking it wrong. Oh, no. There's 3x to the 1/3 power plus c. This is also okay. You don't have to do this, but that's okay. Because remember, whenever we have a number out in front of the natural log, you can pull that up as a power. So that really could be the cube root of the absolute value of that. But you sure don't have to have it like that. But you could. Keep it simple, silly. Just leave it like that, I think, is the way to go for our Calc 1 class. Okay. Let's see what we got next in the hopper. 9, it looks like we're going to bust out our sweet algebra skills, huh? X squared plus 1 dx. So what are we going to do here? Long divide? Oof, does anybody remember how to long divide? X squared plus 1, long divide that into x squared plus x plus 1. And so you think, okay, what is that? Negative, just 1, right? Just 1. So 1, and then I multiply that here. Do the distributive property, x squared plus 1, and then I make them both minuses, because I always minus that. And then bring down the x, and so that's the remainder. So as a long division problem, would be 1 plus the remainder over the divisor, x over x squared plus 1. So 1, this is the actual quotient, is 1 plus the remainder over the divisor. X squared plus 1, all right? And so now we can work it like a regular problem here, dx. All right, so let's do it to it. We could do 2 integrals, so you can do the integral of 1 dx, that's going to be easy, plus the integral of 1 over x squared plus 1 times x dx. And so let's do our u substitution. So u is equal to x squared plus 1, du is equal to 2x dx. Of course, we don't have a 2 there, so divide out the 2. So 1/2 du is equal to x dx. And now let's sub in everything. Dx plus 1 over u. And then that 1/2, I'll tell you what, just because I'm running out of room here, we're just going to sneak that 1/2 out in front and put the du there. All right, and now we can integrate. So antiderivative of that is just x. Antiderivative of this is 1/2 ln u, and then plus c. And now remember, u is equal to x squared plus 1. So we have x plus 1/2. Oh, don't forget the absolute value. The absolute value. Ln the absolute value of x squared plus 1 plus c. Okie dokie. Wow, that was a way old callback. Long dividing to get 2 terms that we could work with. Oof. All right, let's see. The log rule is sometimes disguised. The following. Let's see. What are we doing here with this? X plus 1 1. Oh, yeah, that's going to be a problem, isn't it? Okay, let's look at this one. This one is a bit of a weirdo, too. So... All right, so we say, all right, well, we're going to do 1 over x plus 1 squared of 2x dx. So we're saying u is equal to x plus 1, so du is just equal to dx. And that presents a problem because we have 2x, and there's not an x there, so we have to do that trick to solve for x. So x is equal to u minus 1. So now I can get rid of that. I can pull the 2 out in front. I can have this as x plus 1 squared. I have to simplify that. Ay caramba. So this is going to be a bit of a mess, isn't it? All right. Well, let's do it to it. We got x dx, and we got x plus 1 squared, like that. All right, so now I know x, I can't have that. So I'm going to replace that with u minus 1. Dx is right there, that's du. So I'm going to replace that, and I'm going to replace that with u. So this is what I have. The integral of 1 over u squared. X is u minus 1, and then dx is du. So I replace that, I replace that, I replace that. I'm all u's now. Let's call that u to the negative 2 minus 1 du. 2, and then let's do the distributive. So we're still simplifying. Remember, like bases add terms. So there is our little 1 over u. And then minus negative 2 du. And now I can integrate each one, like one at a time, with the 2 kicker. So let's do it. We've got 2 times, do the integration. That is going to be ln of u minus add 1. So that's u to the negative 1, and then divide by whatever the power is, negative 1, and then plus c. That should be it, right? And then we got to put the x's back in. Don't forget to put the x's back in. I got to fix it up a bit. So remember, there's a 2 being multiplied by everything, and so we could do that. This is going to be positive. So there's a bunch of stuff going on. Let's fix that up. ln u, and then that's plus 2 over u. And then that's plus 2c, but that's just c. See, we can always cut out c. You don't need that. Because if you double c, it's just a different c. All right, so we're there. And now let's put in our x's, and then we'll be done. So 2 ln of x plus 1. Absolute value of that. Plus 2 over x plus 1 plus c. And that should be my answer. 2 ln x plus 1 plus 2 over x plus 1 plus c. All right, that is lovely. Oh, and you could pull that up as a power if you wanted to. Not gonna, but you could. All right, let's look at 34. What are they telling us to do? Integrals of 6 basic trig functions. Again, you should definitely know 1 and 2 on this, but then the other ones, not really. So let's take a look. Top of page 34. 1, you should know the integral of sine u du is equal to negative cosine u plus c. And number 2, you should definitely know that the cosine u du, and the integral of that is sine u plus c. So those you should know. These, not so much. You don't have to worry about it. U du is equal to negative ln of the absolute value of cosine u plus c. We actually did that one in the notes, but you don't have to know it. Don't circle that one. 3, 4. Don't circle 4. Don't circle 3. Cotangent u du is equal to ln of sine u plus c. Again, we could work those, but 5 secant u du ln of secant u plus tangent u plus c. You don't have to know that one. And 6 cosecant u du. I mean, write them down. You might see them in the homework or something, but you will not see 3, 4, 5, or 6 on the test in this class. And count 2, it might pop up in there. You never know. Count 2. So don't memorize just 1 and 2. You should know 1 and 2. That should be burned into your brain. All right, so then let's see what we have. Derive. Do the derivative of this. Okay, so the derivative, secant x dx, that's just going to be the integral of secant x dx. So we have that already, right? Secant x dx is ln of secant x tangent x plus c. So all right, I guess not sure what we're doing here. You could multiply top and bottom, I guess, if you want to see why this is that. Why is this that? You can multiply top and bottom by secant x tangent x plus secant x plus tangent x. Both numerator and denominator by that. And so if you do that, then you get secant squared plus secant tangent. And then on the bottom you get secant x plus tangent x. And then you say u is equal to secant x plus tangent x. And then you say du is equal to secant x tangent x plus secant squared x, which is exactly what the top would be, dx. And then it's like 1 over u, and that's the top. And then when you take the derivative, when you take the integral rather, the integral of that is going to be ln du over u, because this is u, this is du, so it's just du over u. And so that is our ln of secant x plus tangent x plus c. So that's sort of why this one works. You multiply, it's a really weird operation to multiply by, but that's how it works out. All right, let's look at 12 and 13. And, 14 and 15, we're not too worried about those either. We'll do this quick. Quick. Faster. So 12 cosine of 2x dx. So u is equal to 2x. Du is equal to 2 dx. So 1/2 du is equal to dx, because they don't have that on there. So we have 1/2 cosecant u of, oh, it should be cosecant, sorry, du. And so then what do we have? Negative 1/2 ln of cosecant of 2x plus cotangent of 2x plus c. So we're just, yeah, you're just doing the cosecant thing of that. And then you got to put the 2x's back in. And it was negative ln, so that's where the negative came from. All right, and then the last one on this page, on 34, is x tan of x squared dx. So u is equal to x squared, du is equal to 2x dx. So we've got to do the 1/2 du equals x dx. And we got the x and the dx up there. And so it you're looking at 1/2 tan u du. 1/2 the integral of tan u du. And so then when you do that, it's negative ln. So you got negative 1/2 ln of the absolute value of the cosine of x squared plus c. All right, and let's look at the last page, 35 of 5-6. Done with 5-6. What are we doing here? Extra integration formulas involving logs. U ln u minus u plus c. Well, that's lovely. Log. Okay, so here, we're going to do these really fast. We're not too worried about these. These, again, are a little more Calc 2, a little less Calc 1. Log base 3 of x dx. So if you have different bases, let's say a is equal to 3, u is equal to x, du is equal to dx, and then we're looking at log u du. So it's just x over ln of 3 times ln x minus 1 plus c. So it's just, you're just plopping it into the formula on the top of the page. That's all. Okay, and then the last one is 9x plus 2 dx. So u is equal to 9x plus 2. Du is equal to 9 dx. So we got 1/9 du is equal to dx. And so 1/9 times integral of ln u du, which is 1/9 times 9x plus 2 ln of 9x plus 2 minus, really? 9x, a quantity 9x plus 2, and then plus c. So that's the formula directly above there. All right. So that's that. Page 35. Whew, that was it. Finally, we are done with this section.